Please welcome Microsoft Azure Partner Architect, Strategic Planning and Architecture, Bryan Kelly.
Thank you. It's great to be here in Lisbon today. I hope you're all having a great summit. I'm going to talk today about Microsoft's journey on open source hardware. And that journey started back in 2014. Microsoft joined the Open Compute Foundation. I realized this morning when I looked at this slide that this is our 10-year anniversary of joining Open Compute, so we're going to have to do something this year to celebrate that. Maybe on the global summit, we'll see. Since joining the Open Compute Foundation, we've made systematic contributions towards standards and interoperability of hardware and infrastructure, from Project Olympus in 2016, Project Cerberus in 2017, right through to Calyptra in 2022, and then OCP Safe last October in 2023. But I'm not here to talk about the past or a history lesson on what we've done in OCP. What I really want to talk about is what's the next chapter? Where are we going? And to understand the next chapter, we have to look at what are the emerging trends, what's going to influence future innovation. And we have some spheres of influence that we've narrowed down, and some of them are confidential cloud. Confidential compute, we see significant shift in workloads towards confidential compute and cloud, looking for higher levels of security, isolation, and protection. Generative AI. So this one is truly transformative. It's going to revolutionize the full stack and re-architect everything from data centers, critical infrastructure, right through networks, workloads, the design of that infrastructure. Quantum resilient cryptography. And this one is not to be underestimated. This has the potential to be very disruptive. All of the security protocols today that rely on asymmetric key exchange, those security protocols are impacted by quantum computers. And while that runway to quantum might seem long, some of the breakthroughs that are coming through generative AI are shortening that runway. So we need to pay attention to this one as we look at the next wave of innovation. This next sphere of influence is the physical infrastructure. It's heavily influenced by the demands from generative AI, and we'll dig into each of these a little bit later. And composable architectures. As we see this full stack revolution and this full stack change, things are going to change at different times. They're not all going to change at once. We're going to see higher levels of disaggregation, and we need greater modularity to make sure these changes can be brought in to our infrastructure. So I'll delve into each of these shortly, and then we'll see how it comes together towards the end of this talk. But confidential cloud. So as I mentioned, more workloads are shifting towards confidential compute, and OCP is helping to deliver unparalleled transparency and consistency already with some groundbreaking projects. We have Project Calyptra. If you haven't heard of Calyptra, it's an open source silicon root of trust, an essential component in secure devices. It anchors the chain of trust in hardware, and it provides integrity guarantees to workloads that run on that hardware around the security state of the hardware. We have OCP Safe. It's an audit framework to ensure that security is implemented correctly in secure devices. And we have OCP Lock, which is an open source key management solution for storage devices that manages keys in hardware so they're not exposed to software or firmware, to protect keys in use. So confidential compute, what is it? Well, you've probably heard about encryption of data at rest. It's pretty standard in cloud environments. Anytime data is stored to disk, it's always encrypted. You've heard about encryption in transit. Anytime data goes out over the network, it's always encrypted. Well, confidential compute is about the protection of data while in use through protected and attested trusted execution environments. Confidential compute is particularly interesting for generative AI, where strong protection is needed around models and strong protection is needed around data. AI runs on some of the most sensitive data sets. Confidential compute is also making new scenarios possible, like multi-party collaboration. Parties can come together trusting only the hardware, and they can share data analytics without sharing their actual data. So confidential compute is a sphere of influence we need to track. Generative AI, this one is transformative. And I say with generative AI right now, we're very early in our journey. We're super early. We're at the innovation and investment phase. And what I mean by that is every transformative, every technology that's become transformative in our society and has had an impact on society goes through phases. There's pioneering research. There's a light bulb moment that everybody sees. There's innovation. There's this stage, the innovation and investment, intense innovation, intense investment to reach infrastructure at scale, and then value creation where it starts to come together. And to help understand that, we'll overlay it with the electrification of our society. With the electrification of our society, back in 1750 and 1800s, we had pioneering research in 1750 from Benjamin Franklin. And then we had Volta's research and discoveries in the early 1800s. And then over half a decade later, or half a century later, multiple decades, we had Edison's light bulb moment, where the world seen the potential of this electrical research. And it's funny, back then, there was a lot of skeptics still. And Edison made this claim, that's true today. He said, electricity in the future will be so cheap that only the wealthy will burn candles. And how true is that today in our society? Electricity has truly become pervasive. We only talk about it when we don't have it. It's there, it's ubiquitous. But what it took decades of investment and innovation to reach infrastructure at scale. And think about the infrastructure at scale for the electrical grid and how long that took to build out. That's where we're at in our AI journey, to get to value creation, true societal value creation. And if we overlay where we are in our AI journey, we'll see we had the pioneering research that brought us large language models. We had a light bulb moment for many with ChatGPT. It's the fastest downloaded application. It had 100 million users in its first 3 months. And we're right here in this innovation and investment phase. And some innovation is happening. We're seeing it. We're also seeing value creation, early value creation that tells us we're on the right path. Some of the innovation that we're seeing with confidential compute, like I mentioned earlier, we have confidential AI already. And that's going to be essential for growth. We have an innovation. Microsoft collaborated with NVIDIA and brought Azure confidential GPUs based on NVIDIA H100. And this provides model protection and data protection. And for sensitive workloads in the cloud, this is going to be essential. And it's going to help move towards that infrastructure at scale and help scale. But more innovation is needed. We need more to get there. The investment is happening. We see the investment in Silicon Valley. We see the investment here in Europe. We're seeing value creation, early value creation with co-pilots, improvements already in healthcare, legal services, sciences. And with value creation here in science, it's particularly interesting. And it's interesting because science fuels technology, and we know technology fuels science. And now we have this momentum, and we're starting to see momentum. We're starting to see some AI breakthroughs. Microsoft in the Pacific Northwest Laboratory discovered a new solid electrolyte using AI. And this dramatically reduces the usage of lithium-ion or lithium batteries by 70%. And what AI did is it took 32 million potential candidates and it whittled it down to just 18. And then from that 18, took it to 9 and helped researchers make this discovery. And that's not it. In the field of quantum computing, Microsoft released a co-pilot for Azure Quantum to help people to reason about complex chemistry and data material science. Microsoft published achievements on qubits, a high resilient qubit. That takes us to phase 2 of quantum. We have these phases, these levels where we see foundational. It was noisy qubits. This next level is resilient qubits. That takes us. These qubits are 800 times more resilient than the level 1. And this is what it takes to get to scale on quantum computers. And AI is helping facilitate these breakthroughs, and that's why we need to be paying attention to quantum. I'm going to jump to quantum resilient technology, or quantum resilient cryptography. As I mentioned earlier, this is critical. We don't want to underestimate this sphere of influence. Europe leads with the Data Sovereignty Act. We should be paying attention here with quantum, because all security is getting impact. Protocols that rely on asymmetric cryptography for key exchange, they become compromised by a powerful enough quantum computer. The National Institute for Science and Technology is publishing specifications on how to use these new algorithms. And here at OCP, over the next few days, you're going to hear a lot about an Atoms Bridge Accelerator. OCP, in conjunction with CHIPS Alliance and the Calyptra Consortium, are going to bring an open source quantum accelerator. So we can help overcome some of the challenges that we've had in the past with hardware development timelines being long. And the complexity, we're not dealing with elliptic curve and single points on a curve. These are lattice, this is lattice cryptography, it's multidimensional. And then in the past, we've had fragmentation and slow adoption. We don't have that runway anymore. We need to move fast on quantum, and OCP is helping to get us there. And then this sphere of influence I want to talk to is about our physical infrastructure. You've heard a lot about this today, a lot about power. In March, NVIDIA mentioned that there are 120 kilowatt racks. We've gone from 1632, and we're jumping to 120 kilowatt racks for AI. We need to invest in cooling solutions and power delivery solutions. I'll talk about sustainability. It's sustainability too. Microsoft has purchased 19 gigawatts of sustainable energy. It's not enough. We've procured 19 gigawatts. It's not enough. We need more innovation there. It's a drop in the ocean. We need to work together to innovate on that. I mentioned modularity. We need to build systems that are modular in design, so we can transform technologies. They're going to evolve at different rates, and they can't all be refreshed or retrofitted. So we need to find a way, as this infrastructure comes on, that it connects into existing infrastructure. And then lastly, I want to talk about composable architectures, because it is full stack innovation, and inside in each of these verticals, we're going to see innovation. Within each one, silicon innovations, platform, network, all of these are going to change. And these are what we call the verticals, but then we also have the horizontals that go around them. They have to be designed with sustainability and with security in mind. And this can't be done alone. This can't be done by one company. Microsoft can't do this by itself. We need the community, and we're here at OCP because we believe in OCP, and we've seen the innovations that have been brought through Calyptra, SAFE, and many of the other innovations here. And if we look at OCP, there is no other community on the planet that looks across the full stack. And the breadth is here, and the depth is here. So I'd encourage you all to get involved in these work groups, in these projects, and not just one. Innovation often happens on the seams between many. And with that, I want to thank you all for listening. Thank you.